Port mirroring is the process of copying network packets from one port to another. Network packets can then be analyzed on the mirrored port for diagnostic reasons. This could be one reason to implement a network appliance or intrusion detection system. Not only can you mirror just one port, but you're also able to mirror a full VLAN. Just remember that port mirroring doesn't guarantee that all traffic from source to destination will be received. In order to mirror a port, we need to make sure it's set to the default VLAN. Let's go to VLAN Management and Port VLAN Membership. We scroll down until we see port 26. There's currently a VLAN attached to this port that isn't the default one. We're going to select GE26 and click Join VLAN. This gives us a window to modify the VLANs associated with this port. The box on the left contains available VLANs, and the one on the right contains attached VLANs. I'm going to move VLAN 30 off of here and put VLAN 1 as the attached VLAN, leaving it set to untagged. Let's click Apply and close the window. To set up a mirrored port, we go to Administration, Diagnostics, and then Port and VLAN Mirroring. Next, we click Add to set up our first mirrored port. In our case, we're just going to mirror our uplink port since we don't have a set device we want to mirror. This way, all packets will be captured with devices connected to this switch. We're going to drop down and select GE26 as our destination port. Our source interface is GE28. There's the ability to only select incoming or outgoing traffic with RX only, receive, or TX only, transmit. But we're just going to select both, click Apply, and close the window. Keep in mind that the status will be set to not ready if the source or destination ports are down. In our case, we just don't have anything hooked up to the destination port yet, which is what's causing this. Remember to save your changes. Click on the flashing red Save button over here, click Apply, and then click OK on the second window that pops up. STP, or Spanning Tree Protocol, prevents loops and broadcast storms when multiple switches are connected. Things like these can cripple your network or even make it unusable. It's common to have this on by default anyway, but there might be tweaks you want to make that fit your network topology and set up better. It's a good idea to do your research before you enable any global or interface level settings, as this could affect your network's functionality. First, we're going to look at STP global settings. These are located under Spanning Tree and STP Status and Global Settings. We can see that STP is enabled and operation mode is Rapid STP. This allows faster STP that doesn't create forwarding loops. The classic STP option provides a single path between any two end stations, while multiple STP detects layer 2 loops and mitigates them. Multiple STP instances can be tied to individual VLANs. This is a good approach if you're looking to limit your impact on loops per VLAN. Next, we're going to look at individual STP interface settings by selecting STP interface settings. We have one device connected to port 1. Let's go ahead and select that port and click the Edit button. We know this port is set up on an access VLAN, which means it's most likely meant for an end-user device. We do want STP set to Enabled on this port. However, it's a best practice to enable BPDU guard on an access port as well. BPDU, which stands for Bridge Protocol Data Unit, is a collection of frames that contain information about STP. In this case, access ports don't need to have an influence on the STP topology. This job should only be reserved for switches and bridges, not end-user devices. We're going to select BPDU guard, click Apply, and close the window. To copy these settings on multiple access ports, click Copy Settings down here, and then copy the config from port 1 to other known access ports. Be mindful where your trunk or up-trunk ports are, as those shouldn't have BPDU guard turned on, like here on port 28. To save our changes, we're going to select the flashing red Save button. Then we click Apply to apply the running config to the startup config and click OK on the pop-up window. That's it for this demo. In this demo, we showed you some basics of Spanning Tree Protocol ports. We also showed you how to set up a mirrored switch port.